Hello class. Today we're going to be looking at compounds. This is chapter 5, mainly section 1. And so these are the 6 questions we're going to be looking at today. Defining compounds, what they are, and we've already defined that in chapter 3, but we'll look at it again. Why do atoms form compounds? We talked about that in the last chapter, chapter 4. Explain why the properties of an atom are different than the properties of a compound, and we'll kind of explain what that reason is in today's notes. Differentiate between ionic bonds and covalent bonds, which are 2 types of bonds we're going to be looking at in this chapter. Number 5, what are oxidation numbers? How do you know an atom's oxidation number? And what are polyatomic ions? Okay, so looking at our PowerPoint today, making of compounds, this again is chapter 5. First we're going to define compounds. So compounds are a combination of 2 or more elements and they are chemically combined. So it's not just a mixture, it's actually that they are chemically put together. They share or take electrons or sometimes give up electrons. And so we'll talk about the differences for those today. Once you have a compound, you have new chemical and physical properties. Because once they are put together, for instance, sodium and chlorine, they are put together chemically and in such a way that they will have new properties once they've been put together. You could maybe think of this as maybe you as an individual, you have certain characteristics or personality traits that you have when you're alone, but then when you're with maybe your best friend, maybe you act sillier or maybe you're more of a listener, but you might have new characteristics that kind of people recognize when you're with somebody else or when you're with a best friend or something like that. It's the same idea. So our individual atoms by themselves behave a certain way, and then when they're combined with something in a compound form, they will have new characteristics or new behaviors. And most of the matter around us is in the form of a compound or a mixture of compounds, because the atoms themselves are just too reactive alone that pretty much everything in nature that we are exposed to is a compound or a mixture of different compounds. So compounds and properties, we're going to give you an example of this. For example, sodium is a shiny, soft gray metal, and it reacts violently with water. So if we're looking at physical properties, that would be shiny, soft, gray, and metal. And chemical property would be that it reacts violently with water. It actually will have a little explosion. Chlorine is a greenish yellow gas, and it can kill you if it's in the air. It basically suffocates you. So again, physical property, greenish, yellow, gas. And then chemical property is that it actually kind of takes the place of oxygen in your red blood cells and it will suffocate you. However, if you put sodium and chlorine together in a chemical form, a compound, we get something that's used every day, table salt. So we have completely new properties from the elements before when they were by themselves. When they come together, so they were pretty unhappy by themselves. Sodium was pretty unhappy, reacting violently. Chlorine was pretty unhappy, it would kill you. But you put them together chemically and we have something that they're much more stable, they're happier, and it makes your food taste good. So compounds, when we actually make the compounds, they're made through chemical bonds, and these chemical bonds are just an attractive force. They're just pulled together through this force. And really, if you get into the details, it's through the force of the positive and negative parts, the protons and the electrons. And a chemical formula is how we write a compound. So that would be, an example would be H2O. It is the chemical symbols and then how many atoms of that element that you have. So why do they form? Well, we go back to our octet rule where the goal is to become stable or to be happy. And stable and happy is basically 8 outer electrons. Now, we did talk about how there's other ways that we can look at the electrons, and you'll get to that more when you go to chemistry class. But in general, they want 8 outer electrons. And so in order to reach that goal of 8 outer electrons, they will bond with something else. And so pretty much everything on the periodic table is going to bond with something except for the noble gases. That's group 18. They're happy the way they are. Now these atoms will just use their valence electrons to form compounds. So as a reminder of what valence electrons are, hopefully we know that word by now. Valence is just the outermost electrons. Now, we could represent these in a dot diagram, which we've talked about in the past with chapter 4. We can show just the valence electrons and look at how many electrons are going to be transferred or maybe shared with another atom. So an example of a dot diagram, for instance, chlorine has 1 outer electron. Sodium has, or sorry, chlorine, I said that backwards. Chlorine has 7 outer electrons with our dot diagram. And chlorine, we'll change our color here. Chlorine has 7 outer electrons. Sodium has 1 outer electron. And so sodium will want to give away this 1 and give it to chlorine to fill that empty spot. And when it does, they both will be happy, and that produces table salt. So show you another example here. H2O, hydrogen has 1 valence electron, oxygen has 6 valence electrons. Neither of them are stable on their own. They will form a compound to become stable. Hydrogen is represented with the X's, although we just still use dots, but this is just showing you in this example. They will share this set of electrons in order to become stable. So we have 2 forms of bonding. The first one we're going to spend most of our time on is called ionic bonding. And ionic bonding makes ions. Now, if we go back to chapter 4 and think about what that word ion means, it means a charged atom. And the way it became charged was by giving up or taking electrons. So they give up or take electrons. And when that happens, we produce an ion. So this is our example here. We have sodium that has 1 outer electron. We have chlorine that needs 1 more electron in order to become stable. And so what they will do is sodium will give this one up, just a really nice guy, give up that electron, and chlorine will take it, and then they both become stable. At this point, sodium becomes a +1 because now it had 11 protons, and 11 electrons, but now it has 10 electrons. So it becomes +1. And chlorine becomes -1 because it had 17 protons, and now it has 18 electrons. So it becomes -1. And that's where our ion is formed. We're going to skip this example as it's the same exact example I just gave you. And then we're going to look at the other type of bonding, which is covalent bonding. And in covalent, they share the electrons. So both atoms want to benefit from the gaining of electrons, and instead of just taking them from another atom, instead they will share these electrons. So this is an example here. Chlorine, when it's by itself, it's called a diatomic molecule. We had that in chapter 4. And when it's diatomic, that means 2 atoms. And they will combine together with themselves. So instead, here they will share a set of electrons in order to get to 8 outer electrons. Here's another example of covalent bonding. CH4 is carbon and hydrogen, and they share the electrons. Carbon has 4 valence electrons. Hydrogen has 1 valence electron. And so they will share to make both sets of them happy. We won't spend as much time on covalent. We spend most of our time on ionic. Okay, and then oxidation numbers. This is going to tell us how many electrons that an atom will give up or take in an ionic bond. So it tells us what's going to happen if these atoms join up with somebody else, another atom, in an ionic bond. And oxidation numbers you can put on your periodic table. They deal with the number of valence electrons that there are in that particular atom. So it's based on the group that they are in. Group 1 will have a +1 oxidation number because they want to give that away. So some general rules. If they have 1 through 4 outer electrons, the atom will give these away. Okay, and if they have 5, 6, or 7 outer electrons, the atom will take on electrons to get to a total of 8. So we can write these in on our periodic table. Group 1 is a +1. And if you haven't done this yet, take time to do it. Group 1, +1. Group 2 is +2. Group 13 is +3. Group 14 is +4. Group 15 is -3. Group 16 is -2. Group 17 is -1. And group 18 is 0. So this is the oxidation number. Okay, and if we were to look at what that related to in outer electrons, this one has 1, 2, 3, and 4 outer electrons, and then this has 5, 6, 7, and 8 outer electrons. So you can write those in on your periodic table. There's a spot for you on the back of your periodic table in the squares, I believe, and then there's a line that you can write those in as well. Please take time to do that so you have it available for you. And then the last thing that we're going to look at today is polyatomic ions. Now these are kind of unique, and basically what they are is that they are atoms that are already chemically combined, but then they kind of pretend to be atoms. So they are already a compound, but then they pretend to be an individual atom and still bond with something else. They want to have that extra chemical bond, that extra compound made. So basically it's because they're more stable, they're just too reactive on their own, but then once they are in that combination, they can still bond with something else. So they're covalently bonded, but then they make ionic bonds with something else later. So there are a few that you need to write in. These right here you can put on your periodic table. So they are over here. This is what you'll put in as a chart. Carbonate is CO3 and it has a -2 charge. Chlorate is ClO3 and it has a -1 charge. Hydroxide, OH, and it's -1. Put that 1 there, and that's +1. And then nitrate, NO3, -1. Phosphate, PO4 -3, and then sulfate is SO4 -2. So you can put those on your periodic table. All right, so that's the notes for today. Introduction to compounds and why atoms make compounds.